Objective 14, explain how monomers form addition polymers. So I really should have put this back up when we're talking about alkenes, but I totally overlooked it. But we looked at how you can add hydrogen or water or a halogen halide or just a regular halogen. And the other thing you can do with ethene or any other polymer is you can simply add it to itself. So if I have my ethene and somehow the bond gets broken open, I'm going to rotate this 90 degrees so that I'm looking at the ethene with the open bond here and my hydrogens above and below. And I now have my monomer, which can endlessly add on other identical monomers. And you can easily substitute things in on this monomer. If I had a Cl in here, instead of being polyethylene, now this becomes polyvinyl chloride or PVC. In the case of Teflon, you could substitute in fluorines in all four places, and that makes a product we know as Teflon. I mean, there's numerous substitutions. You could do this with polypropylene as well. Now, with polypropylene, it's a little messier to do it because you've got that extra carbon there. And I've got 2, 1, and 3. But again, when you split this open, if you think about turning this 90 degrees, I would have my open bond on each side. This would still have 2 hydrogens here on my first one. And when I turn this sideways, this would have a hydrogen, and then the extra carbon or methyl group simply hangs down here. So always turn these 90 degrees when you try drawing them, because then when I attach another polypropylene, it's easy to see where they keep hooking on. And the other thing you should be aware of is you always leave the open ends on a polymer to show that it's limitless as to how much you can add. The only thing that's going to limit you is the number of monomers available to attach.